In this video, we are going to solve Pearson Edexcel International GCSE 9-1, Tuesday 22 May 2025. Okay, it is a regional paper 1PR, okay, S4SD0, double award over there. This is a regional paper 1PR over there. Okay, if we go for its solution, then I will say there are 110 marks in total are available over there. And before starting to the solution of this paper, I will say kindly subscribe my channel, like the video, share the video if you like it, and if you are getting the proper solution which is needed for its paper over there. And other papers of chemistry, biology, and mathematics are also uploaded. Kindly check those videos also and get the high score in your final exams over there. Let's start towards the solution of this paper there. Okay, some formulas as an insert are given. And remember that the G value will be taken for calculating weight will be 10 meter per second square over there. Okay, let's move to question number 1 there. Here he is saying, okay, some multiple choice questions option is introduced. If you are feeling some option is wrongly corrected, selected over there, then just cross it like horizontal line with there. Otherwise, just fill the box in the form of a square with the cross over there. The diagram shows a truck traveling along a horizontal road. Total resistive force is 16 kilonewton is shown over there, and driving force is being shown as 16 kilonewton over there. The diagram shows the horizontal force acting on the truck. Give the resultant horizontal force acting on the truck. So here I can say that the driving force and resistive force both are acting in opposite direction, this direction and this direction, and both are equal in magnitude. So resultant will be 16 minus 16 will be 0 kilonewton for this. So we can write it there as 0 kilonewton, Z-E-R-O, or you can only write 0 kilonewton over there. So he is saying 16 kilonewton, just remember that 16 kilonewton was driving force and resistive force over there. The driver of the truck has to stop because a tree has fallen on the road. The thinking distance of the driver is 7 meter and the braking distance of the truck is 20 meter. Calculate the stopping distance of the truck. So stopping distance, as we know, that both should be being added for this one. So 20 plus 7, it will give us 27 meters is the total braking distance which is required to stop the truck over there. After that, he is saying give two factors that would affect the braking distance of the truck over there. So I will say here that the proper condition of the road, like it is wet or dry, condition of the road, like it is dry or wet over there. And I can also say condition of tires, like it is new or it is old, like it we can also say that it is tread depth or like that. Also depends upon mass of truck over there. Mass of truck, it is loaded or not loaded, it is required over there. And it is also being depending upon initial speed of truck over there. Truck over there. So this is the main reason which he was saying over there. Okay, let's move to the next section over there, what he is asking. Okay, which of these factors would decrease the driver's thinking distance over there? Road is dry rather than wet. Decrease the thinking distance. No, thinking distance does not depend upon the road over there. The truck has old worn tires. No. The truck is tired. No. The truck is traveling at lower speed. This will would decrease the thinking distance of the driver over there. That the truck is traveling at lower speed, that will be fine for it. Let's move to question number 2 now. Let's look what he is asking over there. The question is about a magnetic field. Diagram 1 shows the poles of the two strong magnets close together. The uniform magnetic field between the poles of the bar magnets. Complete diagram 1 by drawing the magnetic field lines to show a uniform magnetic field. You should label the poles also. So you should label. Okay, I am going to take here North Pole and South Pole over there. I am saying it is North Pole, it is South Pole. Magnetic field lines are originating from this to go towards this in the form of straight parallel lines over there. At least draw 4 to 5 lines to show the magnetic field between both of these poles and opposite poles facing each other. As I said, North Pole and South Pole over there. And parallel lines, equally spaced field lines from North to South Pole. And there will be a proper correct label for North and South Pole over there should be present. This was your labeling the diagram over there in the form of magnetic field. Now he is saying diagram 2 shows a strong magnet attracting an iron block. Okay, it is a strong magnet. It is attracting the iron block over there with South Pole. Okay, what should we say here? The iron block becomes magnetized when it is in magnetic field of the strong magnet. Label the magnetic poles of the magnetized block in diagram 2. The side of block of iron which is closest to magnet's north pole over there should be labeled as south. So it will be north here as that is close to south over there, and so far it should be labeled with north N over there. Now he is saying a student asks, takes the strong magnet away from the iron block. The student suggests that they can permanently use the iron block to attract small pieces of iron. Explain whether student's solution is correct. No, because it is a soft iron magnet material. No, because iron is soft magnetic material. And we can also say here that it loses most of its magnetism when external magnetic field is removed, and it loses most of its magnetization, its magnetization when permanent magnetic field is removed over there. So therefore it will not be strongly magnetic and will not be permanently attract the small pieces of iron over there. Okay, let's move to question number 3 there, where he is saying that this question is about electrical circuit. The table shows the circuit symbols for some electrical components. Complete the table below. Okay. Complete the table by placing tick to show whether each component can visibly indicate the presence of current in the circuit over there. So I can say uh, lamp can easily show the presence of current. After that, light emitting diode LED can also show over there. And this is a fixed or variable resistor. Then I will say electrical component with variable resistor, and fuse will not be taken over there. So I can say here that fixed resistor, no visible change, and electrical, this is no visible change over there. Thermistor, no physical change over there. After that, this is LDR is not showing any type of physical change over there. And ammeter, because he is saying can visibly indicate, okay? And I can say ammeter can show by showing its little bit deflection over there. So visibly, these can only show over there. LDR, variable resistor, thermistor are not able to show the visibly the presence of current over there. The diagram shows that electrical circle containing cell and component X. The graph shows that the resistance of the component X varies with temperature. It means temperature is increasing and resistance is decreasing. Definitely, it will be thermistor. Give the name of the component X, it will be thermistor. This is negative temperature coefficient resistor whose resistance decreases with increase in temperature over there. Okay, here he is saying using the graph determine the resistance of component X when temperature is 50 degrees centigrade. Okay, temperature is 50 degrees centigrade. So it is being taken like this and it should be taken like this. And it is approximately at 50 degrees centigrade because temperature is taken in 50 degrees centigrade. So it is approximately 80 ohms over there. It is 80 ohms to be taken over there. After that, he is saying that the cell in the diagram 1 has voltage 9 volt. Okay. Calculate the current in component X is 50 degrees centigrade. Use the formula V is equal to IR. So I say I need I over there. I is equal to V over R, voltage over resistance. And voltage is 9 over 80. Then I will say 9 divided by 80. 9 divided by 80 equals to 0.1125. 0.1125 ampere there. After that, he is saying that the circuit diagram 1 modified by adding a second identical component X in series with the other component. The temperature of the first component X and second component X are reduced to 26 degrees centigrade. Explain why the resistance of the circuit is affected by these changes. Okay. So the temperature is reduced at 26 degrees centigrade. If we look at the graph, the resistance of the thermistor is what? 21, 22, 24, 26. It is approximately equal to this value 100, 150, 160. So it is 160 ohm at initial resistance over there. On the other end, adding a second identical resistor in series, then I will say total resistance will become, according to series total formula, R1 plus R2. So 160 plus 160 will make us 320 ohm resistance over there. So it is showing that the resistance is increased because the resistor is added in series as the second identical thermistor or component is added in in series. So resistance is increased over there. All right. Okay, let's move to question number 4 now. He is saying a student does an experiment to investigate energy transfer by conduction. The student plans to use the piece of apparatus shown in photograph. Okay, metal bars are there. Temperature sensitive strips are putting in hot water. Okay, the apparatus has four bars made up of from different metals. When the apparatus is placed in hot water, energy is transferred from the bottom of the bar to the top of the bar. The temperature sensitive strip of each bar changes color as the temperature of the bar changes. The time taken for the color change to reach the top of the bar can be used to compare how effective each metal is transferred the energy by conduction. Give three control variables in the student's investigation over there. So I can say here that the temperature of hot water can be used. Temperature of hot water can be used as a control variable over there. Volume of hot water. Volume of hot water can be used over there. And I can also add over there that the length of metal bars, length of metal bars can be used as controlling variables over there. I can also say here that the type of temperature sensitive strip used and the depth to which the bars are immersed. And depth to which the bars are immersed over there. All right. The student has the equipment. Beaker, okay, hot water, stop clock, like stopwatch, clamp, and clamp stand. Design a method the student could use to compare the effectiveness of metals by transferring energy by conduction. Okay, you may draw a diagram over there. So I will say here, first of all, I will say like, okay, first of all, I'm just explaining this, then I will try to draw my figure over there. Like clamp the apparatus vertically, apparatus vertically over there, and using a clamp stand, using clamp stand over there, and pour a measured volume, pour a measured volume of hot water into beaker, hot water into beaker, and then place the apparatus into hot water and place the apparatus in hot water and immediately and start the stop clock, or we can say stopwatch like that. Start the stop clock, and when you are done with this, then observe that each bar and observe that each bar and record the time taken, okay, time taken for the color change, for the color change, for the color change to reach the top of each one, to reach the top of each one there. So this was the method, and the metal with the with the shortest time is best conductor. And the metal with the shortest time is best conductor over there. So this was the method how to go for its complete summarizing over there. Okay. Now he is saying that he has taken aluminium, brass, copper, and steel. Time taken for the color change in seconds 29 seconds, 64, 22, 115. Plot a chart, students' results over there. So I will say here that I will take all the four metals on x-axis, like I am writing here aluminium. After that, I am taking brass, I am taking copper, and in the last, I am taking steel over there. Then I am saying time on y-axis, I am taking time on y-axis, and this is my x-axis, and this is my y-axis to be taken over there. And if I go for the scale of sensible scale on y-axis, then I will have to go from 0 to at least 120, because 115 is on there. So I will go with 50. No, 50 will be too much small. 20, 40, 60, and then 80, then 100 and 120. All right. So if I plot the graph over there, then I will say that the height of the bar for metal to be taken over there will be taken. So for the first one is aluminium for 29. So 20 is there and 30 is there. I am saying little bit small below. It will be going like this. This is to be taken for aluminium. After that, the next one is brass with 64 over there. 60 is there. Okay. 62 and 64. So I will have to go like this to show that this is your brass. After that, I will have to go for copper. Copper is 22. So this is going for this one to be taken as this. And in the last, he is saying to me, go for 115 for steel over there. So this is my 100, this is 110, and this is 115 over there. So I will take it down and also take it down over there. So this is the representation of this data over there. And this is, you can also label these bars that this is for aluminum, this is for brass, this is for copper, this is for steel. So everything can be taken and properly labeled over there. Deduce which metal is most effective at transferring energy by conduction. So I will say most effective will be the conductors that transfer energy the fastest. So if I just observe that copper is the smallest one with 22 seconds, so therefore copper is most effective as the most effective conductor transfer energy fastest. So the fastest time is as the fastest time is for copper in the form of 22 seconds. So it is the most effective, is most effective, it is most effective at transferring energy, by conduction over there. So this is the way how we should go for it. Let's move to question number 5 now. Okay, the photograph shows a cloud chamber used to observe the alpha radiations produced by radioactive source over there. Okay, and the radioactive source is inside the cloud chamber as shown in photograph over there, glass viewing window. Okay, so radioactive source is given over there. Describe the structure of an alpha particle. So alpha particle is identical to, it is identical to, it is identical to helium nuclei, and it consists of, it consists of two protons and two neutrons over there. Okay, if I move more, let's see what he is asking over there. The source is used in cloud chamber contains isotope radium-226. The incomplete nuclear equation shows the decay of radium to 226 into an isotope of radon. Complete the nuclear reaction. Okay, remember that alpha particle is having number 2 here and number 4 here. Like 88 is done with 86 now, and 226 will also be subtracted by 4 over there, and it should be 2 2 2 triple 2 over there. And this is the, whenever an alpha particle is released, then remember that your mass number will be subtracted by 4 and your atomic number will be subtracted by 2 over there. So this is the overall atomic number with 88 to 86 and 226 as a mass number to triple 2 over there. The tracks in the cloud chamber can be seen through the glass viewing window. Explain why the radioactive source is not hazard to the person viewing the cloud chamber. So I will say here as alpha radiations is very weakly penetrating with high ionization over there, and it is absorbed, and it is absorbed in few centimeter of air or a thin sheet of paper, in few centimeter in of air over there due to very high ionization, and glass viewing window of cloud chamber is sufficient to absorb all alpha, and glass window is sufficient to absorb all alpha radiations, so that is not going to reach towards the person, so that is safe. When a radiation is emitted from the source, uh, a white line is produced in the cloud chamber. The white line is known as a track. The diagram shows the tracks produced by radiation from the source, And the diameter of the cloud chamber is also shown over there. Radioactive source. Explain the properties of alpha radiations that can be deduced from the length of the tracks over there. We can say that all the tracks are all very short. The tracks all are very short, even though the diameter of this chamber is very big, and much less than 10 centimeter diameter over there. So we can say this shows that alpha particles have very short range in air. Alpha particles have very short range in air over there. So I can also say that this is because they are highly ionizing and losing their kinetic energy quickly. They are highly ionizing, highly ionizing and losing their kinetic energy very quickly over there. Okay, let's move to question number 6. The photograph shows a rocket is being launched at Canaveral in the United States of America. Okay, it is launched. Army photos taken over there. Okay, he is saying that the table shows the information about the motion of the rocket during the first 5 seconds of the launch. Initial velocity is 0, acceleration 13 meter per second, time taken 5 seconds. Okay, what he is saying, calculate the final velocity of the rocket after 5 seconds. So I will use the simple formula of acceleration is equal to final velocity minus initial velocity divided by time taken. Initial velocity is already told that it is 0. So I will say it is A is equal to V minus 0 over T. So I will say here V is equal to A multiply T. Then I will say that it is 13 multiply 5, and 13 multiply 5 will give you 65 meter per second as the final speed over there. Calculate the distance the rocket traveled during the first 5 seconds. So I will say go with the second equation of motion. S is equal to ut plus half at square over there. U is 0, so ut is gone. Only half into a was 13 and it is 5 square. So I will say here uh, 0.5 multiply 13 multiply 25. If you go for its calculation, then I will say it is 162.5, which is approximately equal to 163 meters. All right. Now he is saying that sketch the velocity time graph and a distance time graph showing how the motion of the rocket changes during the first 5 seconds over there. So a straight line with a positive constant gradient starting with 0, 0 will be shown like in this form. That is for velocity time graph. And then I will say that for distance time graph, a curve with increasing gradient like parabola starting with origin 0, 0 like that, like it should be like this. That is being shown in the form of small parabola starting with the origin 0, 0 over there. Okay, this question is about light. Light is an example of transverse waves. Describe the transverse wave and you may draw the photo, you may draw the diagram to help your answer. So in transverse waves, we can simply say here that if this is the medium in the form of horizontal line, then up, down, up, down, up, down. And it means I can say here the oscillations or the waves are the particles of medium. The waves are are perpendicular over there at right angles to the direction of energy transfer, to the direction of energy transfer over there. The waves are oscillations over there. So this is the transverse wave where it is perpendicular like in this form, perpendicular in this form, perpendicular in this form over there. Okay, he is saying that the diagram shows a ray of light from optical fiber over there. The air is there and optical fiber is there. Okay. The ray of light is incident on the boundary of the optical fiber and air. The ray of light reflects at the boundary, and complete the diagram by drawing a reflected ray over there. Then I will say the reflected ray should be drawn at an angle equal to the angle of incidence inside the optical fiber. Then I will have to draw a normal over there, and I will have to take the another way, and I will say this other angle will also equal to show that it has completely directed inside towards the optical fiber over there. After that, he is saying, explain why no light leaves the optical fiber when the light reflects, because we know that this is total internal reflection. This is total internal reflection, in which I can say angle of incidence is greater than critical angle over there. And in this case when it occurs when light travels at a denser medium to less dense medium and the angle of incidence is greater than critical angle, then total internal reflection is happened and it is not allowing the signal to go out of the medium over there. Okay, here he is saying diagram 2 shows different rays of incident light on the boundary of the water and air over there. I think this is the angle of 90-degree and this is the angle of incidence to be shown over there. Then I will say that if I will have to go for this proper answering, if you are going with the properly taking by your marking scheme under consideration, then you can also go over there, show the refractive index of water is 1.3. Then I will say here, use the formula N is equal to sine R over sine I. Why I use this reciprocal form? Because the light is going from water to air over there. Remember that when you go from denser medium to rarer medium, then your Snell's law or N is equal to sine I over sine R is going to be inverted. And from here you can say sine 90-degree over sine of that angle, which you can easily measure with the help of your protractor. By taking the ratio, you will get the answer of 1.3 over there. This is the question about the solar system over there, where he is saying give the name of galaxy of the sun is in. So it is Milky Way. Milky Way. This is the name of galaxy over there. Neptune is a planet in the solar system. Triton is moon that orbits the planet Neptune. Draw the diagram to show the orbit of Neptune and the orbit of Triton in the solar system over there. Uh, Then I will say here, let's suppose there is a sun in the center and a larger circle for Neptune of orbit around the sun will be taken, and I say this is Neptune over there, and a much smaller circle of Triton orbit around the Neptune will be taken, and that is for Neptune moon over there, that was giving the name of Triton. Triton over there. So this was being taken for the pictorial representation of the data. Now he is saying Neptune orbits the solar system over there with orbital speed 5.4 multiplied 10 to the power 3 meter per second, and orbital radius is this. Pluto is another object in solar system. Pluto orbits with the time period of this. Show that the ratio of the orbital time of Neptune to the orbital time of Pluto is 2:3 over there. So I will say here, first of all, I will have to go for orbital speed formula, that is 2 pi r over t. If I take t as a subject, then t will equal to 2 pi r over v over there. Then I will say I will have to go for this to be taken, and I will go here. So first go for Pluto to go with its time period for Neptune to be taken first over there. So Neptune is having its radius 4.5 10 to the power multiplied 12. 4.5 multiplied 10 raised to power 12 divided by the speed over there, with also 2 pi to be taken over there, and its speed is 5.4 multiplied 10 raised to power 3. If you take it exactly placing in your calculator, then you can get the time period for this one as 5. You are getting the time period for Neptune as 5.235 multiplied 10 raised to power 9. And if you observe there for Pluto, this is 7.8. So it will be given as 5.23 multiplied 10 raised to power 9 divided by 7.8 multiplied 10 raised to power 9. This is gone, and if you divide this 5.23 and 7.8 with the dividing by SEM to SEM with 2.61, you will get approximately 2 over 3. So the ratio of 2:3 can be shown over there. Okay, let's move to question number 9 over there. The diagram shows a spring hanging from a nail. The diagram 1 shows the spring with no weight added. Diagram 2 shows with stationary after have been after a weight has been added and after the weight has been pulled down. Okay, it is being pulled over there. Which energy stores increases the spring in diagram 2 compared to the spring in diagram 1, then I will say that it is because of the weight low, so it is gravitational potential energy, which is because of the gravitational pull of the mass addition over there because of its weight. Okay, after that he is saying the spring is released from the position shown in diagram 3. Describe the energy transfers that takes place until the spring stops vibrating over there. So it is given for 6 marks. So I will say in diagram 3, if you just observe there, in diagram 3 here, okay, I'm just describing it. Just listen very carefully from here. Like in diagram 3, the spring has energy in its elastic store. Like as elastic potential energy, when it released, elastic potential energy is transferred to kinetic energy store as the spring moves upward. And at the diagram 2's position, the energy is partly kinetic and partly gravitational potential energy. The spring continues past diagram 2 and transferring the kinetic energy back into the elastic and gravitational potential stores. And this energy transfers between the kinetic and elastic potential stores continues, making the spring vibrate. And the vibration eventually stops because energy is transferred into thermal stores of the spring and surrounding due to the air resistance and internal friction over there. So remember that if you are not understanding this one, just take it 1 minute back or half minute back and just listen the wording which I said right now for its explanation over there. I'm not writing its answer, okay? Okay, after this, let's move to the next part where he is saying shock absorbers containing the springs are used in motorcycles over there. Okay, shock absorber are designed to compress and expand as the motorcycle moves across a rough surface. A new type of shock absorber has been developed to generate electricity from the movement of motorcycle. The new type of shock absorber consists of magnets that slide inside a coil when the motorcycle goes over a bump. Okay, this is a magnet, this is a coil. Some of the energy that would normally be wasted can be recovered so fuel is saved. Which of these statements best describes the advantage of the new type of shock absorber over there? So he is saying it increases the energy transferred into thermal store of the fuel. No, it increases the efficiency of motorcycle. It's fine over there. And it decreases the speed of motorcycle. Now it decreases the braking now. So you will solve it by placing this cross to be labeled over there. Okay. Explain how the new type of shock absorbers can generate electricity over there. So for this one, I will say that as the shock absorber moves, as the shock absorber moves, then we can say the magnet slide inside the coil, and you remember that this movement cuts the magnetic field lines over there, and we can say of magnet. So this induces the voltage according to in the coil, and I can say this induces the voltage over there and in the coil via generator effect over there, and this electrical energy can be used, for example, to charge the battery. Okay, so this new type of shock absorbers can generate electricity. Over there was the explanation for this part over there. Okay, here he is saying that road X, oh, that's a rough for surface, and road Y is a smooth surface over there. Both are shown over there. A motorcycle travels at the same speed along the road X along Y. Explain why the new tire of shock absorbers will generate more electricity for this motorcycle on road X than on road Y. So it's very easy because the road X is a rough, then road Y as road X is rough, then road Y over there, and we can say on a rough road, we can say on rough road, uh, like X over there, the shock absorber will shock absorber will compress and expand more frequently over there and with larger amplitude. With larger amplitude over there. So we can say here this causes the magnets to move magnets to move magnets to faster inside move faster inside the coil and inside the coil more often over there. So I will say here that if you go more in detail, then you should also add that this induces a larger voltage and current, so generating more electricity over there. Okay, the photograph shows a ring made up of gold over there. Okay, a student wants to determine the volume of the ring. And student measures the mass of the ring several times. Describe how the student used the laboratory equipment accurately measure the mass of the ring over there. So he will use, I will say, use digital meter, digital, digital mass measuring, digital, I will say, balance, and up to three decimal places. Up to three decimal places with the least count of 0.001 gram over there. Used in the form of digital and place the ring on the pan to ensure that it is clean and dry and wait for the reading to stabilize over there. Place the ring on dry and clean pan to stabilize the reading. Stabilize the reading over there. And also note down that take the measurement very accurately and take the measurement over there. Okay, this was the method to measure the mass over there. Now he is saying that the table shows the student measures the mass of the ring. One of the student's measurement is anomalous. Draw the circle around the anomalous value over there. 6.41, 6.402, 6.408, 4.2. So I will say the larger difference is going 411, 408, 410. This is an anomalous value. 1, 2 is approximately equal over there. So this was for anomalous value. Calculate the mean mass. So you will take only the more accurate values which are nearer to each other. So you will take 6.411 plus 6.408. This is the second value. Take the third value 6.410 plus 6.412. Just adding all of these values divided by 4, you will get the mean mass that will approximately equal to 6.410 gram for it. After that, he is saying, uh, oh, that is mean mass is done. Now he is saying the student is given a value of the density of gold. What is the formula for it? Density is equal to mass divided by volume. So density is equal to mass over volume. So volume is equal to mass over density. Mass divided by density, option C will be fine over there. So we should go with it. After that, he is saying here, the student does not know if the ring is made up of pure gold. The student suggests that they could also measure the volume of the ring using a displacement method. Describe which method, calculation method or displacement method will give more accurate. So I will say here that when we go for displacement method or calculation method, then I will say in calculation method, accuracy depends on the accuracy of the mass measurement and reliability of the given density value. If the ring is an alloy, then I will say the given density of the pure gold will be wrong and making the volume calculation inaccurate over there. But if I go with the displacement method, then I will say this directly measures the volume by seeing how much fluid the ring displaces. So it is a direct measurement and does not rely on the material purity over there. If done carefully using a measuring cylinder with a small enough scale, it will give a true volume of the ring, which is more accurate for checking purity. So we can say this overall, if I conclude this, I will say the displacement method will give the more accurate volume measurement for determining if the ring is not a pure gold over there. All right, I think so. This explanation is enough for you for understanding this question over there. Okay, let's move to the next question here, where he is saying a ball is moving through the air with the speed 54.8 meter per second and has mass 159 gram. Calculate the energy, kinetic energy of the ball up to three significant figures. Okay, just use the formula 1 by 2 mv square. So remember that the mass is given in gram, and you will have to take the energy in joules. You will have to convert this into kg, so divided by 1000 you will get 0.159 kg over there. So use 1 by 2 into 0.159 into 54.8 whole square. Place all of them up to in kinetic energy. Then you will just observe that the energy up to three significant figures. If you get its answer, it will be 238.741. And if you take up to three significant figures, you will write it 239 joules over there. After that, he is saying that the speed of a ball is measured using radio waves. The radio wave has frequency 2.9 10 to the power 10 hertz. Travel towards the ball of a source. The radio wave reflect off the ball. The reflective radio wave change frequency depending on the speed of the ball. This change of frequency is Doppler effect. Okay, radio wave and waves from source and reflected wave. Ball 54.8 meter per second. It is going in forward direction over there. Then what he is saying over there, what to do? He is saying that the change in frequency to be calculated using formula speed of ball, change in frequency over source frequency, speed of radio wave divided by 2. So I will say here, show that the change in frequency of radio wave is approximately 1.1 10 raised to power 10 mega 10 raised to power 4 hertz over there. So I will say here that if I need change in frequency to be calculated over there, so I will have to make change in frequency as a subject. Then I will say here that change in frequency is equal to speed of ball multiply source frequency multiply by 2, speed multiply source frequency multiply by 2 divided by speed of radio wave, like speed of radio wave, and the above the speed of ball over there. So if I put all of these values which are given according to the above one data also, so radio wave frequency is 2.9 10 power 10 over there. Frequency of source is being taken as 2.9 multiplied 10 is to power 10 hertz, and the speed of ball was labeled as 54.8 multiplied by 2 divided by speed of radio wave is the speed of radio wave is being taken as speed of light. Wait a second. Yeah, 3 multiplied times power 8. If you just place all of these values in your calculator, then you can observe that it should go with 1.1 multiplied 10 is power 4. 1.1 multiplied 10 is to power 4 hertz over there. You can also check on your calculator. Now he is saying the change in frequency of radio waves happens because the ball acts as a new source of radio waves. The ball is moving away from the original source of radio waves. Explain the change in frequency of radio waves when radio waves reflect off the ball. Okay, so here I can say the ball is moving away. The ball is moving away from source, then acting as moving source for the reflected waves over there, and for a wave source moving moving away from an observer, the observed wavelength the observed the observed wavelength increases over there, since wave speed is constant. Since wave speed is constant, then I can say an increase in wavelength and an increase in wavelength results a decrease in frequency, results a decrease in frequency over there, and this decrease in frequency is the change in frequency measured. All right. Okay, let's check if something else there. No, it is the end of the paper over there. So remember that don't return this booklet with this question paper. This booklet, which is provided to you in the form of formula, no need to return this booklet to the examination hall over there. This was end of your today paper. Kindly subscribe my channel again, I say to you here, and most latest papers of even though October, November, which are going to be released soon, will also be uploaded over there. Thank you so much for today.